Next one, let's look at example 15. A student sits on a freely rotating stool holding two dumbbells, each of mass 3 kg. When his arms are extended horizontally, the dumbbells are 1 meter from the axis of rotation and the student rotates with angular speed 0.75 radian per second. The moment of inertia of the student plus the stool is 3 kg meter square and is assumed to be constant. The student pulls the dumbbells inward horizontally to a position 0.3 meter from the rotation axis. Find the new angular speed of the student. Okay, so we have a student here. So he is sitting on a stool. So this stool is rotating like this. And then the student is holding a dumbbell, two dumbbells on each side here. So each of the dumbbell has a mass of 3 kg. So first, the student extend his arms. So dia extend dia punya arms like this. Di mana the distance of the dumbbells daripada axis of rotation, ni adalah axis of rotation, adalah 1 meter. This one, 1 meter. So apabila dia extend, dia punya distance ni adalah 1 meter. And then initially it is rotating with angular speed 0.75 radian per second. So initial value adalah 0.75 radian per second. And then we are also given the moment of inertia of the student plus the stool. Okay, so kita dibagi moment of inertia student tambah dengan stool, which is equal to 3 kg meter square. And then dia bagi tahu value ni adalah constant. Dia assume it is constant. Okay, so dekat situasi yang kedua di sini, the student pulls dumbbells inward. So now dia pulls lah dia punya arms inwards. So making a position of 0.3 meter from the rotation axis. So now value R dekat sini, this one here is 0.3 meter. And then dekat sini we want to find what is the value for angular speed. Okay, so here we have two situations, initial and final. So initially the speed is this value, and then the moment of inertia is this value. Okay, so now dia cakap moment of inertia yang ni adalah constant. This one here constant. So maksudnya initial dan final adalah value yang sama. So here final we don't know. And then the value for R here. Okay, value R dekat sini pun berbeza. This one is 1 meter. This one adalah 0.3 meter. Now we want to find this value here. Okay, so kita akan keluarkan dahulu formula untuk conservation of angular momentum, which is the sum of angular momentum initial sama dengan angular momentum final. So initial kita ada. Okay, kita tengok apa yang rotate dekat sini. The student, the stool and also the dumbbell. So ada 3 yang rotate. So apabila mereka akan rotate dengan angular speed yang sama. Tetapi moment of inertia berbeza. So sekarang ni kita sudah dibagi moment of inertia of the student and the stool. So we need to find the moment of inertia of the dumbbell pula. So here meaning that kita ada moment of inertia of the student plus the stool tambah dengan moment of inertia of the dumbbell. And then final pun sama. And then this is what we want to find. So, kita kena cari dahulu moment of inertia of the dumbbell. Okay. So, untuk dumbbell, dia akan berbeza. Sebab satu, the position of the dumbbell initially is at 1 meter from the axis. And then at final, dia adalah 0.3 meter. So, akan ada perbezaan lah dekat sini. So, keluarkan formula mr square. So, mass of the dumbbell. Okay, mass of the dumbbell since value R adalah sama kan. This one and this one. Dan kita ada dua dumbbell. So, kita tambahlah. Mass ni akan jadi 6 kg. R is 1 square. So, akan dapat 6 kg meter square. And then untuk final, value R sudah berbeza. So, mass still the same. R dia 0.3 square. So, akan dapat 0.54 kg meter square. So, masukkanlah dekat sini. The moment of inertia of the student plus the stool is 3. The dumbbell 6. And then initial angular speed sama dengan 3 plus 0.54 omega final. So, omega final is equal to 1.91 radian per second.